Okay, good afternoon. Thank you for attending this session. We're going to look at the long-term outcomes of direct drilling on soil properties and weed populations on a trial that was on a challenging Hanslope clay soil over in Cambridgeshire. And this is run over 8 seasons with some sort of long-term results. I'll just start with giving a bit of background on the project, take you through some of the results in terms of changes in the soil properties and the yield and margins that we looked at, and then I'll hand over to a colleague who will talk through the weed dynamics. So obviously the direct drilling here, it's a great opportunity to talk about changing farming systems and approaches, looking at direct drilling and obviously trying to understand how these changes in management practices can actually alter our systems. So we looked at a number of properties, as I mentioned, with regarding to soil, looking at the soil structure, looking at changes in the function of the soil in terms of physical properties, bulk density, soil penetrometer strength, organic matter, other things that we as farmers want to try and improve under these systems, essentially to improve our performance of the crops and build resilience into our soils. As most things, and as I'm sure a lot of you understand, that these changes in soil properties take time to change, which is why 8 years does start to give us an indication as to the direction of change. So the trial, as I mentioned, is on a Hanslope clay soil over in Cambridgeshire. The actual trial was set up as a sort of demonstration for farmers. So rather than having replicated plots on a small scale, we actually worked with a farmer looking at 4 fields on farm and followed his rotation that essentially was not a fixed rotation. It was basically designed just to adapt to the situation of grass weeds. So where grass weeds became more challenging, obviously there was more spring cropping in the rotation. Each field was divided into 3, so we could look at what I call the farm standard. So the farm standard is what the farmer was doing more essentially across all his farmed area. And then we had a direct drill approach that was specifically looking at just direct drilling. And my terminology for direct drilling is very little soil movement. It's just enough to open the slot, drop the seed in and close, no more. And then we had if I just move on to the next slide. Yeah, then we had a managed approach. So the managed direct drill was basically where we needed additional approaches. So it could be straw rake, it could be sort of low disturbance subsoiling, other management tools that could assist in improving the system. In this table, you can see the crop rotation across the period. I've greyed out the first year, so the trial actually started in autumn 2012, and for those, many of you I'm sure will remember that autumn 2012 was a horrendous season in terms of rainfall. It was a really wet autumn, very challenging, so probably not the best year but to start a long-term trial. But essentially we moved to direct drilling in that year, and then we basically started the following year. So all the results I'll present today are from that second season, 2014 through to 2021. So in terms of looking at the longer term impacts, what I've done is looked at how we can classify these, as I say, these rotations that aren't completely fixed. So I've divided them into what I call crop categories. So we can see there that I have a crop category that's essentially first wheat crops. I have a second cereal that's made up of either a second wheat, spring wheat or a spring barley. Then we have the break crops. So originally when the project started, we had oilseed rape, obviously with the challenges of growing oilseed rape with flea beetle. That wasn't sustainable, so we switched to winter or spring oats, and then we had the spring barley part of the rotation. So I've sort of broken it down to look at that system performance because different crops do respond differently, and we'll see that in the next slides. So if we just look at the long-term average yield and margin, so this is basically across that 8-year period. I've looked at each of the systems, so farm standard, which I will call FS, direct drill, DD, and the direct drill managed, so DDM. Essentially, we've then looked at those 4 crop categories, and we can see there that the farm standard generally performs well in terms of yield output. So this is the average yield across that time period. You can see there where we have a first cereal, the farm standard produces the highest yield, and we do see a drop in yield down to about 0.6 tonnes lower with the direct drill system. Now, I know there's a lot where we understand that these systems take time to change. So actually the direct drill transition period, if you like, there's an argument that after, say, 5 years, that actually these systems get bed in and then yields recover. We didn't see this at this type, and I think we'll come back to the discussions as to why that might be the case on this particular soil type. We can see also that the second cereal took a bit of a drop in yield where we were direct drilling. The break crop actually performed quite well. So this is the nuance in terms of the actual systems we're using and the cropping. As I say, different crops are slightly more sensitive to the system than others. So as I say, the break crops were actually performing pretty well under the direct drilling system. And then the spring barley, again, we saw a drop in the yield on average. Now, obviously, there is year-to-year variation, which I'll come on to. Just to consider the cumulative margin. So the margin, when I mention margin, it's a financial margin, and it's based on the crop output, so that's the yield, multiplied by the price of the grain in the season of production. And then we take off our variable costs, so that's the seed, fertilisers and sprays. So seed, fertilisers and herbicides, fungicides. And I also take into account what I call the in-field machinery costs. So that's the cost of any cultivations and the drilling, and then obviously the operations in terms of fertilising, herbicide and fungicide applications and combining. So obviously each business is different in terms of its overhead costs, which I haven't included here. So I've just looked at those sort of margins, as I say, based on the output from the field. And then this is a cumulative margin over the period of the crops. And again, you can see there's some variation there. Again, the farmer standard tends to do quite well. And I'll come back to the farmer standard, as in the system that the farmer used was essentially direct drilling, but where needed, went with a low disturbance subsoiler, and essentially building in the flexibility to suit the conditions is really important, and I'll come back to that point in a further slide. So if we look at yield variation, again, this is broken down by crop category, and this is basically the points that sort of in the middle of each graph is the mean, and then we have what I call the outliers. So you have the sort of maximum and the minimum yield performance within those systems. And clearly, we get year-to-year variation, and that is one of the biggest challenges of any system. And as we know from farming, the weather is such a big driver in how systems perform in a specific year. But generally speaking, variation was greater with direct drilling. So basically, you have a higher risk of growing those crops in those systems. So they can do well, but equally, there is a risk of them performing less well. As I mentioned, the first wheats were down a little bit, but not substantially. The biggest drop you can see there is the top right graph, which is the second cereals, whereby there was 1 year actually where the direct drilling crop failed because the conditions it was drilled in good conditions, but the overwintering of it really challenged its sort of growth and establishment. And when you take account of those inputs on the system, the yield was very low, and that has a bigger impact, obviously, on margin. So one of my other key points today is, as farmers, we're businesses. So are we farming purely for yield, or are we actually farming for margin? So margin is probably a key indicator, as I say, of system performance. In the break crop years, as you can see, in terms of the break crops and the spring barley, again, there was less variation in those systems, but again, generally, the farm standard approach did perform more consistently over the years of the project. In terms of margin, again, you can see there, so the margin does account obviously for those savings in sort of efficiencies in terms of fuel use, working time or work rates for the establishment of the crop. But clearly, when you're looking at the overall performance, with yield being quite a big driver of margin, then there's only so much saving you can make from the system change. So margins really are driven both by the yield, but also any system change, and can be sensitive, as I say, given to the conditions in each season. And you can see that very clearly in that second cereal, as I said, where in one particular year the wheat really struggled, and it really did pull down the margin. Having said that, there's obviously other sort of benefits and longer term indications in terms of soil management as well, from essentially doing less soil disturbance. And we can see that in some of the other measures we did. So one of the measures we looked at is looking at soil strength. So we used a soil penetrometer, and this is just basically altered slightly. So it's a similar line in terms of it's measuring the pressure, pushing in a probe into the soil and measuring the resistance to that as it goes through the profile. And so it mimics the root growth of the crop. What I've done is just change the scale to what I call a relative soil strength, so relative of the root restriction. So the dashed line in the centre of the graph is what I've said is 100%, and that's equal to 1.5 megapascals, and that's where a lot of literature suggests that roots become restricted. So you can see very clearly the differences between the farm standard, which is the lowest line on each graph, and the two lower disturbance systems, the direct drilling and the direct drilling managed. So both those lower disturbance systems have an increase in soil strength, which is not too surprising. You're not moving the soil. The soil is really having to restructure itself. But generally, with the sort of field operations, the actual soil is becoming slightly stronger over time. And that's seen not just in the full rotation, but also in those individual crops. So, for example, I've just taken the example of the first cereal, but it was seen across all rotations. So it is a shift in the system. When we looked at another measure, so soil bulk density is also a good indicator of the porosity of the soil, so how much pore space there is between the soil particles. And we can see, again, over the period of the project, slight differences in terms of bulk density in the surface layers. So we took bulk density measurements both in the 0 to 10 centimetre soil layer and in the 10 to 20 centimetre soil layer. So clearly, where we weren't cultivating, we were literally just going in with a seed drill. The differences in the surface layer were actually adapting over the time. And you can see from the left-hand side, the lines of the direct drilling and the direct drill managed are actually becoming slightly more aligned by the end of the period with the conventional or the farm standard system. However, at depth, we didn't actually see the change. So there was a suggestion there that the general change in that structure was very much a surface effect rather than deeper down the soil profile. It would have been nice, obviously, to actually look at the profile at, say, 50 centimetres and maybe even down to sort of 60 or 80 centimetres to look at that deeper seated change in soil structure and porosity. Obviously, there's a lot of talk about the build-up of organic matter, how these lower intensity cultivation systems can actually change the dynamics of that. This is basically looking at the loss on ignition, soil organic matter over the period. I should say these 4 fields were slightly different on farm. Most of the farm, they removed the straw on the fields that we were monitoring, we did incorporate the straw, so it was chopped and incorporated. And we didn't really see a real change in that organic matter levels between the systems over the period of the trial. Again, probably not too expected, because these changes are slow to change, and obviously there is year-to-year variation. So it's very hard to actually say statistically that there was a main change, but generally speaking, there was not a shift in organic matter levels between the systems, either again at the 10 centimetre soil depth layer or at 20 centimetres. So looking at this in terms of the sort of soil biology, we always talk about, or I've mentioned a bit about the soil structure. Obviously, in terms of soil health, we like to look at the sort of soil physical, chemical and biological properties to get that fuller picture. And so this is using the if you like, the methodology that's been developed through the Soil Health Programme, AHDB, looking at those sort of a number of key indicator properties and benchmarking those for typical soils in the region. So anything that's in green, so it's then colour-coded to a traffic light system. So anything in green is it's okay, it just needs monitoring. Anything in amber means that we need to just be monitoring. And obviously in anything in red means that we need to investigate further to try and understand. And you can see here, these are the 4 fields that were within the study. And then generally speaking, we didn't see too many sort of concerns in terms of actually needed investigating further. You can see one particular field where soil P was quite low. It was lowest in the direct drill approach, but this was probably more of a longer term management of that particular field than any system change that we made. And again, you can see some of the other properties, particularly the bolt density, where actually the farm standard had slightly higher bolt densities compared to the other systems. But again, when you look at the actual numbers, they are within the defined level for that given soil type. So again, it's something they're on the high side, but probably driven by some of the management. These samples were taken in 2020, so it was probably partly that season approach where that may have just created some additional soil compaction that increased those bolt densities. And this is where that wider long-term monitoring of these sort of approaches is important, because this is a snapshot in time. Clearly, soils do change slowly, so we do need to be able to say, okay, so in this season, this gives our baseline. Actually, if we went back in, say, 5 years' time, it would be interesting to see if these patterns have changed, or whether there's, whether some of those reds may have altered just through changes in the management in that longer term. So, as I say, in conclusion, I would say that we didn't see a strong shift in the improvement, if you like, in yields from going to direct drilling within the period of the project on the particular soil type. And as I mentioned, it's a Hanslope series clay soil. It is actually quite a difficult soil to manage, and is probably quite challenging for going very much to a direct drilling approach. And I would like to note that actually, as a farm approach, the farm standard, where they've already moved over time, so they've never really it's quite a large farm, so they didn't really had the opportunity or the time and the cost as well to consider ploughing all the farm. So they've always used a non-inversion system, but actually they've been transitioning from a more intensive, so a deeper non-inversion system to a more flexible approach, as I mentioned, with using a low disturbance subsoiler. And actually on these soils, which probably do need a bit of deeper loosening in the period of over the rotation, then that system gives you the flexibility. And I think that's really my key take-home message from this work, is actually we need flexibility in managing our soils. Now, there's certainly soil types that probably are more suited to direct drilling. I think these heavy clay soils do pose a challenge in terms of that longer term reliance on essentially not cultivating. Now, whether we can do that through other interventions, using cover crops, for example, I think there is possibilities, but I think these things do take time to change. And obviously, as businesses, looking at margins, looking at cash flow, we do need to be aware of if these systems might take 10 years to actually make a substantial effect. There's obviously an economic consideration there as well. In terms of the sort of soil properties, as I mentioned, there was an increase in soil strength, but that may have had a small detrimental effect on yield, but not consistently across the period of the project. And bulk densities, as I say, in the surface layer, there was certainly a suggestion that those were improving over time. So, like with all these things, that we do actually need a longer period of time to really study these effects and try and see what is, as I say, a seasonal effect of the weather compared to the actual long-term system changes, where multiple years can actually start to give us a trend in change of those. But overall, as I say, really the main thing is that we need adaptability to our systems, and we need to have flexibility in terms of when we use particular cultivation approaches, bearing in mind on heavier soils, we can obviously experience very harsh periods of either wet or dry periods where those soils are not so responsive to just going very much direct drilling. I'm going to pass over to my colleague, but we will have a session at the end to take questions.
Okay. Good afternoon. Thanks, Nathan, for teeing this up. Aside from the soil part of the study, it was really important that we did look at some of the weed populations. So the site in question, Hanslope Clay in Cambridgeshire, had a long association with blackgrass. The two systems, this long-term non-inversion system had started to really drive blackgrass pressure across the farm. So it's important that we sort of studied that element in context of the system change that we subsequently put in place. So it wasn't just blackgrass that we saw across the fields. Wild oats came and went as wild oats come and go, and we did begin to see in some scenarios some of the brome species that we've been talking about down the stand come in, but again in very low numbers, and in particular fields actually. So never a very consistent approach, which I'll talk about a bit later, but it's quite interesting considering the length of the study, where we haven't actually seen some of those other weeds that have come in maybe latter years with the use of no cultivation or certainly reduced cultivation. So the 4 fields in question, so on the table there, they did have a starting point. This is in the first year, the level of blackgrass heads that we counted in the first year of study. So one field, very, very low average across the field, and then to the extreme of carrot ground that had this incredibly vast number across the field. We have drop carrot ground subsequently from the rest of this analysis. There was a failed oilseed rape crop in one of the first cultivation slots, but associated actually with the cultivated land only, interestingly. So actually in the direct drilling, direct managed areas, the oilseed rape crop was fine, but that resulted in a very skewed response in terms of the weeds, so we have discounted that. In terms of management, all fields did receive pre-drilling glyphosate and then a commercially recommended herbicide program, but that was always consistent across the entire field. I think maybe a point Nathan didn't necessarily make. We didn't change any other sort of smaller management tweaks across the fields. We didn't change seed rates or anything like that. It was very much everything else was standard apart from the cultivation strategies. So instead of really looking at it in every single year, because of this rotation and because the rotation wasn't set, there wasn't any consistency across the 4 fields. I've just summarised the final, the average weed density recorded in each block across the 8 years. So in 2 of those fields, so in Bendy and in Stargoose, we had this significantly greater association of blackgrass density with particularly the direct drilled, but also with the lower cultivation intensity overall. I think that's something that we'll talk about a little bit later in terms of the weed dynamics, but it was very, very stark, in particular in some crops. And actually what you really ended up with is this greater variation. So in some years, the error bars are actually the standard error across all the samples. And I say in every single field, that variation is greater as associated with the direct drill. So in some years, in some crops, it had the highest levels of control, and in others, as I say, in those particular years that in those sort of second cereal slots, they would have the absolute worst at levels. But interestingly, these weren't always consistent across years. So why was that? And we need to sort of dig into some of the explanatory factors around why we saw these changes and where we saw those changes. So what we've tried to pick out is, say, there wasn't a consistent rotation, there wasn't enough points where we were transferring specifically from a winter wheat crop to a spring barley crop, or etc. So what we've tried to do is just pick up on the transfer between autumn to autumn crops, spring to spring, spring, autumn, etc. So I think it's quite well held that spring cropping is a very well understood mechanism to reduce blackgrass pressure overall in a system. And partly, you're isolating this biological blind spot to some extent where you have this much lower germination density within the spring, and it's mostly front loaded in the autumn. So we did see that. So using back-to-back spring crops in particular, but actually just as simple. So this is the autumn to spring conversion, or the subsequent spring to spring. That's the double break. We did see consistent reductions in blackgrass densities, but most acutely in those reduced tillaged areas. So where you are making significant reductions, you can continue to make significant reductions by going back-to-back spring cultivations when you're not starting to move the soil in between those cropping periods. However, then if you then want to transfer back into your autumn crop, you think you've had 2 very good years, you've got your populations where you think you want them, but you want to start to go back into some crops that can bring you some reasonable income, and you transfer into your autumn crop. And obviously, we have then seen those greatest increases as associated with moving from spring to autumn crops. But really, this is not consistent across these treatments, and it was in the direct drilling that we in particular saw the most extreme increases across these sort of changes in cropping season. And again, so digging down into that, we started to look at the competitiveness of our spring crops. So generally, we really do consider these spring barley and spring oat crops to be very high biomass, above ground biomass, very competitive, can get established very quickly and get above and smother out the blackgrass. However, what we seem to find is that actually in these direct drilled systems, particularly the purely direct drilled systems, they aren't as competitive as we would like, and it's clearly a bit of a weakness in these direct drilled systems in terms of from a weed management perspective. So actually, this overall less competitiveness is really quite quantifiable to the extent that 2 to 10 times as much seed is being produced on a per plant basis. So what we actually normally see is that with spring cropping is there's a double whammy of effect. Not only are you reducing the number of plants in your crop, you're also having this smothering effect, so that every single head, there's less heads per plant. So rather than sort of 8 to 10 in a winter wheat crop, you might get 2 or 3 in a typical sort of spring barley crop. But actually those individual seed heads are then much smaller. So this overall effect is very, very strong. But actually these direct drilled crops, we just are not seeing those quite as effective where we aren't moving the soil, we're not having mineralised nitrogen to help get the crops up and away. I think that's where this consideration, where we aren't changing additional parts of the rotation, where there's other management factors that we could introduce, seedbed nitrogen, etc., to try to get some of these crops away and to combat some of these weaknesses that we seem to have identified across the 8 years. So before I talk about some of the seed bank work, this was there's all above ground counts, both seedlings and heads. We did then at the end of the season, and following the final season, we did look at the seed bank, because I think that's really where we start to see those long-term differences build up. But really, I want to start with, if we are starting to talk about using different systems, we want to think about the life cycle of some of these weeds, and therefore where we might be affecting them by changing those systems. This is a very simplified model of a life cycle centered on the seed bank. We have this non-dormant and dormant seed bank, which you've got phases where seeds are going to move between these dormant and non-dormant seed banks. And then you've got obviously the different layers within that, this sort of 0 to 5 classic period, where we almost like the active zone of a seed bank, and then the deeper levels where seeds are more unlikely to be emerging from, particularly blackgrass that we're talking about. Then we've got this sort of germinating die. So this might be where you're using your herbicides. They are theoretically germinating. If it's a pre-em herbicide, they are germinating and then subsequently cause mortality. And obviously germinate and live, which is where we start to. They feed into the system, affected by crop competition and the season itself. And this then feeds back into seed rain, and these seeds are going back into the seed bank. Other ways in which you might be increasing or bringing in seeds is obviously seed dispersal. So rain, you might have wind, animals, machinery, not only through balers and machineries coming on and off farm, but also through your combine, spreading it from the outside of the field further into the field. And then we also have other ways in which the seeds are exiting the seed bank. So this is decay, so whether it's by pathogens or fungi within the soil, feeding on the seeds, but also just long-term seed mortality. And then predation as well is something that in no-till we need to consider more. So both birds, but some of the mice, insects, invertebrates, and what are the effect that they're having when we're changing the system? How do we change some of the parameters of each of these? This is affecting model, and a certain number of seeds are passing through each stage. So how are we affecting this by changing our system? So obviously we're here at Groundswell talking about regen ag, and I wanted just to take back some of these other ways in which we change our system that we might consider it to be part of a conservation agriculture system or regenerative agriculture before we just talk about no-till. So in cropping diversity, so the opportunities here for weed control is that we're altering the biological niche for some of these weed species. So we might be seeing greater diversity of species but total lower dominance. We might also be seeing opportunities whereby we're going to be introducing some of these new species because we are bringing in more spring cropping. So we're selecting for some of these spring germinating fat hen type species, bindweeds, that we don't see typically in winter cropping. They often give greater opportunities for control, so that might allow us to give longer periods between crops to have better seeds, multiple stale seed beds, in fact, effectively between an autumn and a spring crop. Or it might be that we're having a spring crop that we're now talking about doing chickpeas or soya, that we've got a longer period in the spring. So these weeds that ordinarily might have germinated in a spring barley crop aren't no longer germinating. But they also give us some sort of diversity in the overall modes of control that we might see. So classically, different herbicide modes of action that aren't available, aren't available in a wheat crop, are available in an oilseed rape crop, and that pushes on into some of these other newer cropping species. Cover crops, 365-day covers is a really important part, and so I've just come back to the model on a whole here. So how might this change some of our dynamics of our weeds? So I've got a little arrow there around our seed dispersal. I think that there's a potential that you might increase some of the seed dispersal through cover cropping. So part of that might be that you're bringing novel seeds on farm. So what do we consider a weed? It's not just blackgrass. It might be some of those species. It might be Phacelia in your crops. We could consider that a weed. It might be very easily controllable, but we are potentially risking increasing these types of species. But you also got things like animals, where you might be introducing more bird species coming in, feeding in on these cover crops, on these summer cover crops, and they might be bringing seeds from other places with them. And then are going to have a dramatic effect on some of this germinate and die, germinate and live spectrum of the seed cycle. So in cover crops, we might have risks where we aren't fully killing seedlings that are below the cover crop canopy, and therefore there's a chance that we're going to be allowing mature seeds or seedlings to then permeate into our existing next cash crop. And then no-till, and this then comes back to the work at Childley, and this is to an element some of the predictions. So the big red arrow in the middle was really reflecting the fact that we would suspect that we're going to see an increase in our weed seedling densities within that top period, where we're not getting any burial of seed. But we might have some decreases, so green arrow is positive, a positive decrease in the number of seeds in those lower depths of the seed bank. And therefore, how can we use that to our advantage later on? Again, not too much work on it, but around this sort of decay, pathogens, we're not moving the soil, we're encouraging the soil microbiome to take over and to bring us some element of control from our weed seeds in that soil space. And also predation. I think this is a position, actually, us at NIAB, we've got a PhD student looking at some of this in the more holistic sense, but the predation, where we were leaving seeds on the soil surface, they are more available for birds, mice, insects to begin to feed on, and understanding where that and how important that is in no-till is going to be an interesting part to study in the future. And then obviously this germinate and die, germinate and live part. How does no-till affect our performance of our herbicides? So are we seeing more sort of greater trash? Is that having an effect on our herbicide performance? Is it actually having a mulching effect, which is something we have seen in previous work I think we talked about last year on this very stage, in fact. So that's our predictions. So that we know some of those things we can characterise and we've directly looked at in this project. And mainly that is the seed bank transition. So what we did, we went and tried. We've developed a system that tries to be a combination between very accurate but also able to collect lots of samples over a reasonably quick period of time. So what we've got is within each cultivation system, we put a metal half-metre square quadrat down and dug down very carefully at 5 centimetre intervals and collected the soil, put it into trays, which we're then able to then put in a controlled conditions and allow them to germinate over a period of about 6 months. We were then taking out emerging seedlings, counting them, identifying them, and adding them to the tally. After a period of 3 months, we then were able to dry down the soil, shake it up a bit, break down any clods, and then re-water. So we continued this process over several months to make sure that we completely exhausted any seedlings in these seed bank systems. So that's just a photo of where they are, and you start to pick out already some of the differences in some of those trays. There's no order to them; they're in a randomised order there. You can already begin to see where there's some differences appearing. Within each cultivation, we took 3 samples, so 3.5 metres square. So these are field scales, so but actually versus a coring method, we've actually taken quite a large volume of soil. So this is one of the interesting parts. So what we've got here is we've got the 2 fields we did it in. We only picked 2 fields, so it's still quite, despite it's a much easier process, it's still quite a significant undertaking, this type of seed bank analysis. So we've got sort of in the profile that they sit. So you've got your 0 to 5 in blue, 5 to 10, and then your 10 to 15 in the depth. And this is representing the number of weed seeds per metre cubed. So we've actually converted it to a consistent measure. And the first thing that strikes, or should strike you at least, is that in the direct drill, in the direct managed, where we aren't having this deeper level of cultivation down to that 10 to 15 centimetre zone, we're seeing a very quick build-up and significant build-up in the seeds in that surface. So to the extent that, particularly in Weatherfield, it's most notable, but you've got a 10-fold difference between the conventional, apologise for my inconsistent naming, so the farm standard, there's a 10-fold difference in the number of seeds in that top 0 to 5 centimetre layer compared to the farm standard. So I sort of want to raise some questions. I think it's an area that we haven't looked at enough, and actually some of the studies elsewhere don't necessarily entirely give us all the answers, or certainly not some of them. So it seems that a significantly lower proportion of seeds are germinating from a no-till seed bank, and this is certainly most significant in Weatherfield. I'll just nip back, but we're seeing a 10-fold difference in what should be available to germinate, but we're seeing less than a 5-fold difference in what we're actually seeing in the number of seedlings in the year preceding this. So we aren't, as I say, lower proportion of the seedlings are emerging in these seed banks, but actually the total number is much higher. So as a density when we've counted it, which is why it's important to understand the below ground effects. So populations haven't really exploded. I think it's fair to say, even in Weatherfield, the average density was about 40 heads a metre square across the field. So by no means a perfect situation, but not anything extreme. So it does, in this regard, I think we have to consider that maybe no-till has a greater carrying capacity. So that's the number of seeds that they can cope with and maintain a successful system. So it seems to have a greater carrying capacity of seeds in the seed bank compared to this sort of deep cultivation system where you're bringing up seeds, burying seeds, and actually more of those are germinating, able to germinate in a given season. I think this herbicide effectiveness on plants, and they say we've done some other work, but actually maybe this suggests that in this space, maybe some of this herbicide effectiveness was a bit higher was greater in the no-till than or certainly the level of control in the no-till was greater than the conventional, and whether that is the herbicide or whether that's, say, some of this mulching effect from the straw being returned is something we need to continue to look at. But actually, although this effectiveness of seedlings as a proportion, that might be how it's come across, but there's less crop competition, so actually we are ending up with more seeds being returned for a given plant, which is why we're still seeing this driving amount of increased number of seeds in that top layer. So it's not being an even cycle. The same number of seeds aren't being lost, they are as gained. I think predation has been, obviously, I've mentioned, has been posture to be more important in no-till. There's some really nice work going on in that space, but from this evidence, it's really not significant enough to alter the dynamics overall of a big system over a huge number, over 8 years that we've been studying this. So we need to be careful not to oversell maybe that position, but equally it's a part of the seed cycle we need to have some consideration of and actually try and quantify better. Particularly in a system that we've got lower insecticide use and also greater capacity within the greater biodiversity, the greater, more effort's been taken out of the productive areas to increase our insect biodiversity, and how can we get that into the field to maybe increase this part of the life cycle. So in terms of conclusions, I think some of these long-term no-till systems clearly come under significant pressure from grass weeds, and clearly a lot of that is going to be driven by this previous species strongly represented. So in here, blackgrass was the main weed. Blackgrass has remained the main weed. However, they are likely to be more susceptible to invasion from other grass weeds. As I say, we only saw sort of snippets of that throughout the 8 years, but it was only in those no-till areas that we were seeing any level of invasion at all. So although it wasn't persistent, we did seem to see that was where those risk factors were. The management of these grass weeds in a reduced tillage system is potentially on a bit of a knife edge. We have got a huge abundance of seeds in that area ready to germinate. So understanding why maybe they're not is possibly important, but obviously they are there. So if we have the right conditions, we could end up with some very severe infestations, and we did see that in certain years where those no-till systems had by far and away the greatest levels of weed infestation. So these no-till systems, they're going to be highly reliant upon pre-sowing glyphosate to make sure that we can get these stale seed beds, so we can try to drive down the population in some regard. But they are also going to be highly reliant upon effective in-crop control. So that's not just herbicides. We have got other methods now, whether we start to look at some of the robotic technologies, the electrical weeding type technologies that don't undermine the no tillage, no soil movement element. But we do need to, they are highly reliant upon having these tools, and maybe starting to shift away from herbicides earlier and take on some of these newer tools could be advantageous if we want to maintain a reduced till system. And then this sort of change in dynamics, I think, is something we need to, us at NIAB will continue to look at. We have access to one of these fields, so it's going to be interesting to keep going and maybe come back in 5 years' time to see where we've come to again in that field. But clearly, eroding this surface layer is going to remain a priority in terms of weed control and trying to drive that population. So trying to drive the risk that we're going to have these almost crop failures as a result of significant weed infestations down, and to make sure we've got a more a reliable system going forwards. More thanks on behalf of Nathan, who obviously started this project 8 years ago. I came in it was on my 3rd day at NIAB. I was sent out to Childerley. But yeah, thanks to Martin Jenkins and Rob Witherow and the overall farm team at Overhaul Farming for their, it wasn't just doing the farm system, so they had to go out and do some special tasks for us and being very generous in taking care of us while we were at the site. John Deere UK, who we did a lot of the work with the support of John Deere, so we thank them, and then obviously our colleagues and our staff who spent the 8 years digging a lot of soil holes, counting a lot of weeds. So yeah, they're very, very grateful for our colleagues. It's come together to a really nice project. Okay, I think there's a mic, so if you've got any questions.
Have you done, you haven't involved perennial crops, obviously, in this. So looking at, for example, herbage lays, what's your sort of educated guess as to the effect that they're going to have on grassweed numbers in an arable rotation?
So I think when they're applied correctly, they can have a really positive effect. Your you're going to be cutting and removing in some regard or grazing, so you're going to have periods of no seed return to the soil seed bank. It's also considered how you're returning those areas back to the arable cropping. I think so. The in and the out is very important. So if you're so what we have seen is that when we've actually done this over for 2 years, we put in grass and then brought it out. It wasn't necessarily herbal lay, but it was just grass. We cut it, so we had no seed return. Even after 2 years, going back into no-till, we still had significant levels of weed pressure. Whereas if we convert it back into arable through ploughing, we then had almost nothing at all. So that was only 2 years in some scenarios. So I think it's more important about the in and the out. I think during the herbal lay, just be very vigilant that you aren't getting seeding. I think we have seen, I've put a herbal lay in for 3 years. It should be perfect, but actually you clearly have been getting some level of seed return from some of these weeds in there. So I'm being very vigilant within those. It's not easy. You look around the herbal lay behind us, going to try and find some weeds are difficult, but try to keep your eyes open for these weeds in those systems.
In another long-term project I've been managing, where we have had an opportunity to look at herbal lays. So we're part of a SARIC-funded project. We've had a 3-year herbal lay, and then we're back into an arable rotation. And the long-term trial allows us to look at different cultivation approaches. So as Will said, that sort of coming in and coming out of the herbal lay is really important. So we are monitoring that. We were actually quite impressed, and the host farmer was really impressed with how that herbal lay had performed. But as Will said, it's really important to look at that in season, if you like, management of the herbal lay. And if you haven't got livestock to graze it, actually mowing it and cutting it at the right time to reduce that seed return is going to be really important.
Hi there. Just going on from the results you've got, what would you change next in terms of dealing with the weed populations that you've got? Would you look at things like increasing seed rates, or is there another place to go now to deal with that weed population for direct drilling?
Really good question. So I think if you were starting it again, I think from my perspective, really starting it again, you'd probably try and take, looking from a weed perspective, you would be increasing your seed rates in the no-till to get higher plant population initially. Absolutely starting point. I think also start to look at some of these tools that are contributing to effectively a zero tolerance approach. So in blackgrass, we've got tools like the top cut collect from Zern, or even just some sort of weed surfing device where you're cutting the heads off prior to shedding. Maybe not so much for blackgrass, but some of these seed mill type technologies as well, because they can contribute to basically this zero till approach, which I think is clearly so important in no-till, so you aren't allowing that to build up. So for the farm now, I think actually what did they do? I think they ploughed one of the fields. I think they did get a little bit extreme, that carrot field, which you didn't really include in some of the results. I think that you do have to accept that there might be a time where you need to reset if you allow it to build up over a number of years, and use that time to reset. Other work from colleagues has shown that you've made all these advances or potential advances in some of your soil health, soil structure. Ploughing doesn't completely erode that. It might set you back a year or two, but if you know you're going to stay in that no-till system, you're going to build those structures back up much quicker, despite ploughing. So don't be afraid of the plough, but equally there are technologies available that we can take on to keep the weeds at bay in these systems.
Yeah, and just to add to that, obviously, any of these system studies are obviously quite hard to manage in terms of the science. So as a scientist, I'm always wanting to control my variables, having the same drilled the crop the same day for the different systems. That's from a science perspective. From a practical perspective, obviously, you would adapt your system to the conditions and to your system. And that's when we it's really challenging to measure those system changes, because actually, as I say, what the practical sort of farmer would do and what a scientist would do may be slightly different. But it's certainly, I would be really interested to continue, as Will said, we've got one field that we are able to still monitor, and it would be interesting to continue that. And maybe look at, if we were to set up another trial, start to consider how we could look at that system effect if we were going to do direct drill, adjust those drilling conditions, maybe increase seed rates, all those management factors we can control, but actually make use of to improve or potentially improve the performance of that system.
Yeah, I think just there were crops there that Rob did not want to drill. you know, from the no-till point, I don't want to drill it, but you know, that's the science part. So either we might want to drill earlier to try and get good conditions, or we'd have said, no, I'm just not drilling, I'll put it into a spring crop. So that's where we saw some of the weaknesses, where maybe it's a downside of the science sometimes.
Thank you. Just going back to the earlier comments on the biological health of the soil, I noticed that the earthworms didn't really change amongst the systems, and was there any other metrics that you thought that were going to, you know, enlighten us more, or did you think you'd see something different?
That's really good. I mean, yeah, to be fair, the actually earthworms I thought might well be one of those indicators where we would have seen a change. We were returning the residues. You know, there's certainly good evidence to show that earthworms need a regular source of food, so those residue returns in what I thought would have increased those, but we didn't see that. Now, obviously, the challenge is, as we've mentioned, you know, those system drivers, the conditions, the seasonal effects probably do, you know, make it more difficult to look at a significant change. I mean, there are other soil measures, soil health measures, indicators we could do, looking at sort of the microbial, at least like microbial respiration, that may have shown at least an increased activity level, but yeah, like all these things, in hindsight, it would have been good to... Yeah.
I have a question. If you would design a car, would you design a car with one wheel?
No.
How many wheels to make the mobile system work, to come from A to B?
I think I know where you're coming from. And it's absolutely, in terms of the situation, the scenarios, there's one system change on its own will not make, you know, if you're adjusting your system, there's a number of factors that you're looking to change.
Yes. So from the scientifically point of view, it's completely correct to have the reductionistic approach. But I think the system is not working like that. And you make a big difference when you combine things. So in Holland, we did the same research since 2003. And then they were disappointed about the effect of no tillage. And they did also what's the influence of cover crops, mixes, manure, compost, and so on. You know, what's the influence of the one factor? And it was all disappointing. And then they say, since 3 years ago, okay, now we have to integrate, go to multi-factor analysis. And they saw completely different results. So I think that's exactly when you are on a regenerative agricultural approach, more holistic. And I think that's the difference. So when I see this, okay, I understand you are completely right in a scientifically point of view. But is it the truth, and is the ecosystem working like that?
Yeah, no, I absolutely take your point, and I think as a scientist community, actually, I was at a long-term experimental conference last week, and there was a really good discussion around how we can actually design these experiments that are holistic in terms of their system performance, and it's something, yeah, that we absolutely are mindful for. But obviously, it is challenging because you're having all those multiple factors, and what even works on a long-term site 20, 50 miles down the road on different soil types might not be the same. So it's a really good, interesting situation to be looking at. But I do accept your point that we need to look at it as a holistic system.
I think the only thing I'd add is we did work closely with the farm as a whole. So we weren't like an island among this oasis of cover crops and, you know, fully conservation agriculture systems. This was working with the grower himself. This is what he wanted to look at. There's an element of that, I think it's fair to say. So, I completely agree. I think when you're building a systems approach, it's right that to change this, you know, one factor, it might not be the right factor to change. But in this scenario, the farmer involved, that's what they wanted to look at. They weren't interested in trying to look at cover crops and complicating their system as a whole. They were actually trying to simplify their system. And whether it's right or not, but it wasn't just a scientific approach. I mean, it was in terms of the experiment, but the farm itself we're working on, this is what they were doing. So there was an element of this was reflected practically across the farm as well. And say rightly or wrongly, but that was, just wanted to add that as well.
Yeah, just following up on that previous question and your answer just now, I think you've actually answered it. Doing what the farmer wanted to do wasn't probably scientifically the right thing to do. Was this whole experiment over 8 years set up to fail, to show that blackgrass and compaction and zero tillage on a heavy clay Hanslope series soil was going to fail?
Good question. Potentially, yeah. I mean, there is again, there is that aspect of trying to design a system where, as you say, we may have wanted probably from the outset to try and build in approaches. I've been doing lots of work with cover crops. I would have loved to have cover crops as another management tool, but as my colleague mentioned, actually the farmer was quite keen to look at these systems, trying to look at what, because he farms quite a large area, how these more simplified systems would benefit him. And I think, yes, we might have sort of come out with some conclusions that could well be questioned on other approaches or other sites. But in terms of what we found on this particular farm, as you say, with the high blackgrass pressure, which is going to put these conditions under quite great challenges, actually having some adaptation, as I mentioned, with the farmer and the way he approaches the cultivations and the direct drilling, I'm not sure whether, even if we did some other, control traffic farming using cover crops, might not actually allow us to completely go down that direct drill route on this particular farm. There are other system challenges that might preclude that. So, but yeah, I do completely see your view, and we may have had some limitations on which hopefully we've been open with, our design of the trial and how it was structured.
Okay, I think if that's all the questions, thank you very much for coming. I appreciate the end slot of the day. Appreciate you all hanging around. I think the Soil Farmer Award up next, 5:30. So interesting to see who's won that for this year. So, but otherwise, thank you very much.